Dear students, welcome to sixth lecture of this course. In this lecture, we are going to discuss PLM and types of automation. So let us start with PLM or Product Lifecycle Management as it is called. It is a strategic business approach that applies a consistent set of business solutions in support of the collaborative uh, creation, management, dissemination, and use of product definition information across the extended enterprise. Um, that means the starting from the creation of a product or anything which you want to create. That is starting from the conceptual design, its management. For example, you are going to design one engine, starting from its conceptual design up to its management of information, using that information for other applications, and use of product definition information across the enterprise means all the activities, for example manufacturing, inspection, and all that, and even assembly, packaging, maintenance. All these issues are to be handled within the framework of the product lifecycle management. And then spanning from product concept to end of life, integrating integration of people, who are the people who are going to use that information, processes, because you are going to do some kind of design activities, then you are going to do manufacturing, you are going to do inspection activities, etc. All these activities are also centered or handled in the PLM management systems, and this also includes the business systems and information, which is to be used for some other activities. Therefore, PLM forms the product information backbone for a company and its extended enterprise. This figure gives you an overview of the what product life cycle is, because now in this lecture we'll focusing on use of computer systems for product life cycle management. But the product life cycle is something which is related to the all the functions related to the life cycle of a product, starting from design to manufacturing, planning, manufacturing planning, maintenance, distribution, inspection. And this is a representative figure. All the activities are not actually recorded in the slide, but this give you a fairly good idea of what product life cycle is and what is a product life cycle management. In computerized system or computerized environment, you have the in the product life cycle includes the use of database which is related to the product. It may be the your geometric model, it may be your information about the assembly, or what are the number of components being used in the assembly, what kind of components, and this is to be used with the help of different technologies, like for example computer, this CAX means the computer aided technology or concurrent product development. So these are the technologies which are used. In the next slide I will give you an overview of all the symbols which are being used in this slide. Then you employ different methods, like design for manufacturing as assembly is a method with which you are incorporating manufacturing and assembly related considerations within the design. And this is a product data management, and this is the concurrent engineering methods which are being used. And there are number of tools, like number of tools related to computer aided design, number of tools related to manufacturing, number of tools which are related to or there may be one tool also, computer aided quality assurance and all that, and MRP and computer aided inspection. So all these tools are making our product lifecycle management are useful for product lifecycle management, and these things are used tools are used to manage the processes, like starting from conceptualization of a part, going to realization, or this may be manufacturing, then use phase of the part, and disposing the part of the product. And there are different functional departments or people who are making this happen, starting from design people, engineering people, department people, then suppliers, procurement. I'll just give you one example of this product lifecycle management. Suppose you some company, Maruti Suzuki, is going to develop a new car. Okay, and it has a concept, prepared a concept to discuss that concept with the its stakeholders. What are those stakeholders? It may be the people from the marketing department, it may be people from the engineering analysis kind of a department, or it may be the people from the regulation department, or it may be people from the different suppliers or OEMs, original equipment suppliers, okay, manufacturers. For example, for designing a car, you need to have some kind of a steering system. Now, there are some companies who are specializing in steering systems. So, they form an essential, you can say, essential component or essential resource for designing that steering system for a new car. Okay, so all this information, when this is shared in a systematic manner with all the stakeholders, whether it is marketing, service, okay, and even customer sales, and these is forms part of the product life cycle. That means all the life cycle issues are being handled at the design stage itself, and you are managing the life cycle of that particular product with the help of a system. Okay, and here are the different terminologies that has been used in the previous figure, like CX means computer aided technologies. This may be referring to computer aided design, computer aided inspection, computer aided analysis, etc. Then PDM, product data management. Okay, then MPM is manufacturing process management, CPD is concurrent product development. Then these are the methods and concepts that has been indicated in the previous figure. NPDI is new product development and introduction. DFM is design for manufacture and assembly. DFSS is designed for Six Sigma. ETO is engineered to order. That means some kind of tailor-made products. This may be useful. Then these are the list of tools. Many of you are already aware of: CAD, CAM, CAE, MR-based material requisition planning. EDA is electronic design automation. Then CAI is computer aided inspection. CAQ is computer quality assurance. MRO is maintenance, repair, and operations. PPM is product portfolio management. Then, who are the people, who are the companies which use PLM? There are a lot of companies: aerospace and defense, automotive, consumer goods, energy, financial, food and beverages, government, healthcare, high-tech electronics, industrial, medical devices, and pharmaceutical. So all meaning thereby, most of the companies employ product lifecycle management tools to develop their product as well as to manage their lifecycle issues. Then there are many PLM solutions that can be added to the core technology of PLM. So these are the enabling tools which help you to improve the efficiency of the PLM systems. This list is not exhaustive, but here are some of the examples. like bill of material management. For example, I gave you an example of an engine. So an engine, if it is a four-cylinder engine, will typically require four-cylinder, four liners, four pistons, then four connecting rods, but one engine casing in which all these things will be housed. So from the CAD model of this assembly of this engine, of course, you have details of each and every part, but you have the detail of the assembly. How many components of each part are to be, how many number of each part are to be used for assembling one engine. Then CAD file management is another aspect that can be used. Then concept development, detailed design, and document management. So all these things are part of the PLM systems. Okay, so there are number of PLM software systems or solutions which are available. Here I have the list of the vendors or the suppliers and what are the tools, name of the tools or systems or software they provide. Like I would like to mention a few important one which may be relevant to you, like Dassault system. Uh, uh, I gave you example of Aerofall. This is the same company which is using making SolidWorks and CATIA, and they are providing Innovia Matrix 1 and Innovia Smart Team, which are typically systems for managing the product life cycle. And then you have PTC, the same company which is providing Wildfire and ProHear Wildfire. This is again a very popular wind chill, which is a product lifecycle management software. Then you have SAP PLM and Siemens, which is the company which is providing you NX. This is providing Team Center, which is again for the teams to do collaborations and design their product, yeah, by including all the life cycle issues. Okay, so what is I would like to add that in this PLM system, each and every user, for example, I gave you the example of a Suzuki developing a new car model, and it wants to share some information with the steering system supplier. Okay, but it doesn't want that all the details of the car, the concept they are preparing, should be shared with the suppliers, so they can provide access to they can provide certain rights and limit their access. Okay, so that the only those features or those information are available to that steering system designers, which is useful for them. So this is the level of control which is provided by the PLM software solutions. And then second aspect which I want to discuss in this lecture is the type of automation. So a lot of there are basically three kinds of automation in of the production systems. One is the fixed automation, which we also call it as hard automation, and the second one is a programmable automation, which is also called as soft automation, and the third one is a flexible automation. So let us discuss one by one these three. Fixed automation refers to the use of special purpose equipment to automate a fixed sequence of processing or assembly operation. All of you may have heard of Model T, made by Ford in during in the 20th century, 1920s, near about the First World War time. And each that is a very good example of a fixed kind of automation. So they made a lot of products of the same kind to reduce the cost of a single unit of the Model T. So it is a kind of a mass production where everything is fixed, and you can the rate of production is the main thing. So each of the operation in the sequence is usually simple, involving perhaps a plain linear or a rotational motion or an uncomplicated combination of two. So advantages of this is It is having low unit cost and automated material handling is there, and you have high production rate. But disadvantages are high initial investment and inflexibility in accommodating any product. So if you want to make a new design of car, it is not possible with this. And then you have the programmable automation. This is high-end automation where you can have lot of flexibility as far as the design changes are concerned. So in this, the production equipment is designed with the capability to change the sequence of operations to accommodate different product configurations. You know? And advantages of this are basically flexibility in the design variations, and it is very much suitable for batch production where the typically the your number of the quantity of product you want to make is low. And disadvantages are the high investment cost because you need programming in each and every step, and then lower production rate is available than the fixed automation. So you can make use of CNC machines and industrial robots or programmable logic controllers and this kind of programmable automation. Then the third type is the flexible automation. In this, it is an extension of programmable automation. It is a in this system is capable of producing variety of parts with virtually no time lost for changeovers from one part style to the next. Okay, so this is a mixture of basically the fixed automation and programmable automation. So of course, in this the lot sizes can be bigger, and you can have flexibility in design variation, but not that much because you are compromising between flexibility and mass production. Okay, so continuous production of variable mixture of product is one of the feature and advantage, and this is flexible to deal with product design variation to a great extent, not to a very large extent, but uh, so there are of course disadvantages which are associated with this, like medium production rate, high investment, and high unit cost relative to fixed automation. And this figure gives you an overview of the comparison of these three kinds of automation. When you go for high product volume of production, then you have the fixed automation is the best one. Okay, I think it is- okay, small correction was there. So on this axis you can see that there is a lot of flexibility in terms of the product variety, and here on this axis you have the product volume. So fixed automation typically represents low product variety and high product volume or volume of production, and flexible automation is in between. You have medium product variety and medium production, and programmable automation represents high product variety, had a high amount of design changes, but you have to compromise with, of course, with low production volumes.